Hey AP, Tennyson here, and it's time to do some internet review for the AP exam 2021. Now, if you were in class, you got this review in person. If you are not in class, you're taking the digital exam, then you are getting this review now. Here we go. So we're going to create a scenario where we have a connection between some devices, and we're going to go from there. So we're going to try to play out a real scenario. Here we go. Without further ado, imagine a connection is formed between you and youtube.com. We've got you as that little computer looking thing up in the top left corner, and youtube.com as the traditional form for a server, which is a 3D cube, but it's not a cube because it's not square. It's a I don't know what it's called. You tell me. But there's a thing down there. That's how we make servers. Okay, here we go. What global interconnected network makes this connection possible? Well, it's the internet. You've heard of it, and we usually use a little cloud symbol to represent the internet. It's not just the cloud, it's the internet. But what is the internet, really? Well, you might recall that the internet is a large mesh of interconnected I should say that the internet is all the interconnected devices on the globe. Everything that's connected to the internet is a member of the internet. That's what's so beautiful about it. But once we leave ourselves or we leave youtube.com, we're out on the big wild west of the regular internet, and that is basically abstracted for the purposes of AP CSP as a mesh of interconnected routers. And what you can see, I want you to notice that all of these routers have multiple connections to other routers. There might be a single point of failure in there if I forgot to draw a line, but generally the idea is that all of these routers are connected to one another through multiple connections that are highly redundant. That's the actual internet that I would say most network engineers are talking about. Now, bonus knowledge, AP doesn't really cover most of the devices that exist on the internet or all the other devices that could exist, like switches and things such as that. But layer 2 and layer 3 switches, there's so many things that could be out there. But we'll just stick with talking about the routers for now. So what is a router? Well, like we said, the internet is a mesh of these interconnected devices, many of which are routers. And routers are simply special computers designed to route traffic. At least when traffic gets to the router, it's a packet. And so routers route those packets across a network. That's a router's job, is to move traffic among networks. And the internet is just a giant network, so routers are moving packets all across the internet. The other thing to note is that if one router or path fails, there are many backup paths. This makes the internet redundant and therefore fault tolerant. So if one particular connection here breaks, there are plenty supporting connections to make sure that traffic gets where it's going. Okay, so what's next? If we're connected, how do we get to YouTube? Fair enough. So you know that as a user, you're going to go and open a browser and you're going to type youtube.com into an address bar. Don't forget your HTTPS to make sure it's secure. But you've typed in youtube.com. What else has to happen? There's a lot going on here. And for the purposes of AP, we don't talk about all of it, but we talk about some of the coolest and most important fundamental things. So first of all, how does our computer know where to send this request for youtube.com? The first thing that we should note is that every device connected to the internet must have an IP address. Now, in the case of AP, we're sticking with just IP version 4 addresses, even though we ran out of those a long time ago. Thanks to subnetting and many other fancy tricks, we're able to keep just populating IPv4 addresses all over the place. But really, IPv6 is the way we're going in the future, which is a 128-bit address. We'll never run out of those as far as we're concerned within the lifetime of the universe. So anyway, we're just going to talk about this in the term of IPv4 address because every device is going to have some kind of IP address. IP addresses look like this. They're composed of 4 octets, which have a value that will range from 0 up to 255. These IP addresses are completely random. I've just made them up, but they're both valid. Now, like I said, every device connected to a network must have an IP address. But what does YouTube.com have to do with an IP address? Surely there is more, and there absolutely is. We're going to talk about domain name service. So DNS, or domain name service, is what allows us to resolve URLs like YouTube.com to IP addresses, the sending and receiving address of the internet. So how do we sort of relate these two? Well, we will ask a DNS server, hey, what IP does this URL, youtube.com, map to? And DNS will reply with an authoritative, correct answer because it's supported by a system of many domain name service servers, which are all communicating to make sure we get accurate DNS results. And it's going to tell us that YouTube, more accurately www.youtube.com, equals 92.41.8.417. And so we're able to move our traffic across the internet correctly. Now, examples of domain names are things like youtube.com or code.org. There are multiple elements to web addresses in general, but we won't discuss those in our overview of the internet for right now. Okay, we know where we're going, now what? So we've got a little path built out to youtube.com from us. What's happening next? We need to establish some rules for going out here on the internet and having a conversation. We call those rules internet protocols. That's the rule for how any conversation with the internet or on the internet should work. Generally, in technology, we use the word protocol to describe the rules for any kind of transaction or operation, but in this case, we're talking about internet protocols specifically. So a conversation between you and YouTube could go something like this. We might say, hey, YouTube, I would like something. YouTube says, oh yes, hello, YouTube here. You would like something? Yes, I want to watch 10 hours of Minecraft. Okay, I understand you want to watch 10 hours of Minecraft. Is that correct? Yes, that is correct, YouTube. And there is no need to take that tone. I am a computer. Here is 10 hours of Minecraft. Please let me know when you got it. Okay, I got the Minecraft video. All right, so this is a conversation where we are kind of talking back and forth about what's going on, right, between us and youtube.com. So when devices have a conversation on the internet that ensures packets are received completely and in the correct order, that is an example of the transmission control protocol. Alternatively, hey YouTube, I want to watch a live stream of people eating chicken nuggets as fast as possible. Okay. So when devices have a conversation on the internet that does not guarantee delivery or reliability, that is called User Datagram Protocol, or UDP. Let's compare the two. This is the battle of the protocols, right? So TCP is highly reliable. It guarantees delivery. It guarantees the sequence that the packets arrive and make sure that they are coming in the correct order, and it can reorder them if they are out of order. They might get out of order because the routers that each packet takes can be different, which is just amazing if you really think about it. TCP is slower though, but it's going to be used on anything that requires reliability. That's a lot of stuff on the internet. Most web applications, for example, if you're logging into your bank account, if you're logging into your YouTube account, if you are scrolling through Instagram, most of that is accomplished through TCP. Now, UDP is not reliable at all, really, but it's quite a bit faster. And the most frequent applications for UDP are things like voice calls, so voice over internet protocol is going to use UDP, or some variation of UDP, live streams, anything that's happening live, like live video, live voice, all that kind of stuff, typically uses UDP. Now, there's a lot of protocols out there. There's some that are actually proprietary to certain systems. For example, like Cisco Systems has proprietary protocols for Cisco voice phones. but we're not really getting into the weeds on this. And this is not a Cisco-sponsored YouTube video for AP. All right, is there anything else? Well, the question is, what is YouTube ultimately really delivering to us? Like, how does it give us a page with stuff on it and videos? The answer is HTML. HTML is what makes every web page on the internet. It stands for Hypertext Markup Language. The set of rules for how HTML is transferred across the internet among devices is contained within the Hypertext Transfer Protocol, HTTP, also sometimes seen as HTTPS, which basically just means secure HTTP. Most websites that we rely on today use HTTPS to make sure that our transactions are secure thanks to asymmetric encryption and the public and private key system developed by super smart people like RSA. Now, we're not going to get into that right now, but if you don't know your Diffie-Hellman and your asymmetric symmetric encryption stuff, you better go learn it because that's probably on the exam. Surely you're thinking, that is all that I need to know about the internet. Well, the truth is, in the vast sea of technology on the iceberg that is the internet, you are seeing the very tippy top, and the iceberg beneath is enormous. But for your burgeoning technology mind, we're almost done. Okay, so here's our picture of our internet connection, our conversation with YouTube.com so far, but let's zoom in a little bit on just you for a moment. The Earth does revolve around you. Now, if you think about it, it's not just a bunch of routers, it's not just a computer. Really, if we take it all the way down to the least abstract level, or almost the least abstract level, we find binary, right? We find the ones and the zeros that are responsible for all digital information. If it is digital, if it's on a digital device, sometimes we say if it's on a computer, it's binary, but that's a poor way to say it because even though computer is such a poor term because we think about this thing sitting in front of us, but your phone is a computer, your microwave has a computer. You probably can get a coffee cup with a computer in it at this point. I'm just looking at my desk and there are coffee cups here, so I'm trying to imagine things that could also be computers. Here's a picture frame. You can't see it. It's here in front of me. It has my beautiful family on it. But this could also be a digital picture frame, which would make it a computer. Okay, all of it's digital, therefore, it boils down to binary, which is just amazing that we can represent all these systems with ones and zeros. But what is the binary representing? Truly the least abstract thing we could talk about is the actual electrical signals, optical or light signals, or even waveforms that communicate the binary across these devices. If this connection between us and the router is completed with an Ethernet cable, it's a copper connection, therefore electricity is being used. If for some crazy reason at home we have a fiber optic cable between us and our home router, which we won't, but we could, that would be an optical connection or one made with light. Most likely you're connected to your router at home wirelessly. You certainly are using the wireless feature on your router when you are using your iPhone or Android phone. It's not a brand specific conversation. So, it all boils down to this physical form, the physics of it. So don't forget that. Don't forget these least abstract forms of communication. Okay. Now, so this whole thing, all of this is just binary. It's a bunch of binary, conversations and transactions occurring. It's like the Matrix. Look at that beautiful Matrix thing. But don't forget that it's ultimately just a bunch of rocks with electricity shooting through them. That's what your computers are. Don't be intimidated by your computer. Don't be intimidated by code. It's just a bunch of rocks that we shot electricity through, and now we can do amazing things with them, like share TikTok videos. Groundbreaking. And that's truly the end of our internet review. I hope you enjoyed it. Please stay tuned for probably not any more review videos this year.